أعزائي طلبة وطالبات الثانوية العامة القسم العلمي رياضيات لغات، أهلا بيكم في حلقة جديدة من حلقات برنامجنا برنامج ديناميكس. النهاردة إن شاء الله هنستعرض مع بعض موضوع motion of a body on a rough plane. سبق ودرسنا مع بعض موضوع motion of a body on a smooth plane smooth inclined plane، وعرفنا إن في حالة البلين لما يكون smooth يبقى ما عنديش force of friction والبادي بيتحرك under the action of force بتأثر على البادي ايا كان الدايركشن بتاعها، وكمان الام جي ساين ثيتا اللي هي الكومبوننت بتاعت الويت in the direction of the line of the greatest slope downward the plane. النهارده ان شاء الله هنستعرض مع بعض موضوع لو كان البادي بيتحرك على بلين والبلين ده كان راف بلين، فايه الظروف او ايه الفورس اللي هتشتغل على البادي in this case. Dear students of grade 3 secondary, welcome to our math program. Today we have dynamics. Our lesson today is motion of a body on a rough plane. Motion of a body on a rough plane. If the body is in equilibrium on a rough plane under the action of a force acting to move it, then the friction force is the static friction in this case, and the coefficient of the static friction is denoted by mu s. But if the body moves on a rough plane, then the coefficient of friction is the coefficient of kinetic friction mu k. Now let's start with the first example. A rough inclined plane of length 250 cm and 150 cm height. A body at rest is placed on it to slide downward the plane, and the acceleration of motion is equal to 196 cm per second squared. Find the coefficient of the kinetic friction and then find the velocity of the body after it travels or cuts 200 cm on the plane. Now we have a body placed on inclined plane. The length of this plane is 250 cm and the height is 150 cm. Then tan theta equal 3 over 4 and sine theta equal 3 over 5, cosine theta equals 4 over 5. The acceleration of motion 196 meter per second squared, and the body traveled 200 centimeter on the plane, or the distance s equals 200 centimeter. Now n equals mg cosine theta. N equals cosine theta 4 over 5. Then n equals 4 over 5 mg. Now we can write the equation of motion of the body. MA equals mg sine theta minus mu kn, because the body moves with two forces, under the action of two forces. The first force, mg sine theta, which is the component of its weight in the direction of the line of the greatest slope downward the plane. And the second force, mu kn, which is the friction force, the kinetic friction force. And mu k is the coefficient of kinetic friction in this case. Then m times 196 equals mg sine theta minus mu k multiply n, which equals 4 over 5 mg. We can cancel the m from both sides. Then 196 in the left hand side equals 3 over 5, which equal sine theta multiply 980 minus mu k times 4 over 5 times 980. Then mu k equals half. Now what is the velocity of the body at the end or after it travels 200 centimeter? We know that v power 2 equals v naught power 2 plus 2as. And the velocity v power 2 equals the initial velocity 0 plus 2 multiply 196 multiply 200, then the velocity v equals 280 centimeter per second. Now we move to the next example. A body of weight 800 Newton is placed on a rough inclined plane, inclines at 25 degrees to the horizontal, and the coefficient of the static friction between the body and the plane is equal to 0.35, and the coefficient of the kinetic friction is equals to 0.25. Find the force in each of the following cases. First case, F makes the body about to move upward the plane. Second case, F is the minimum force that moves the body upwards the plane. The third case, F, the force F prevents the body from sliding, where F acts in the direction of the line of the greatest slope upward the plane. Now, the first case, the body about to move upwards the plane. And we have N equals mg cosine theta. And the equation of equilibrium is F equals mg sine theta plus mu s n. Now, F equals m, the mass of the body, which equals 800 Newton, 800 gram, multiply sine 25 degrees plus 0.35 times 800 cosine 25, then the force equals 591 0.86 Newton. In this case, the force equals 591.86. The second case, N equals mg cosine theta, with the equation of motion is F equals mg sine theta plus mu k n, then F equals 800 sine 25 plus 0.25 times 800 cosine 25, then the force equals 591.86 Newton. In this case, the body moves upwards the plane. Now, the third case, the force prevents the body from sliding. We know that N equals mg cosine theta. The equation of motion of the body in this case is F plus mu kn equals mg sine theta. F plus 0.35 times 800 cosine 25 equals 800 sine 25. Then F equals 800 sine 25 minus 0.35 times 800 cosine 25. Then the force equals 84.33 Newton. Now we move to the next example. A body slides on a rough plane, inclines at 45 degrees to the horizontal if the coefficient of the kinetic friction between the body and the plane is equal to 3/4. Prove that the time taken by the body to travel any distance if the plane is equal to twice the time taken by the body to travel the same distance if the plane is smooth, supposing the body starts to slide from rest in both sides, in both cases. Now, the first case, the motion on rough plane. The initial velocity of the body equals 0, v naught equals 0, because the body is placed on the plane. And n equals mg cosine theta. Theta equals 45 degrees, then n equals root 2 over 2 mg. Now the equation of motion of the body. ma equals mg sine theta minus mu k n. M is the mass of the body, multiply the acceleration, equal sine 45, which equals root 2 over 2 mg, minus mu k, which equals 3 over 4, multiply n, or root 2 over 2 mg. We can cancel the m from both sides. Then the acceleration a equals root 2 over 2 g minus 3 over 4 times root 2 over 2 g. Then the acceleration equals root 2 over 8 meter per second squared. Since s equals v naught t plus half a t1 squared, t1 the time in the first case, then S1 equals v naught t plus half a t1 squared equals 0 plus half times root 2 over 8 g t1 squared. And then the displacement S1 equals root 2 over 16 g t1 power 2. The second case, the motion on smooth plane, smooth inclined plane, and the initial velocity v naught equals 0 and the n equal mg cosine theta, which equals root 2 over 2 mg. What is the equation of motion of the body in this case? The equation of motion is ma equal mg sine theta. ma equals sine 45 equals root 2 over 2 times mg, divided m in both sides. Then the acceleration a equals root 2 over 2 g meter per second square. Now we can use the rule s equal v naught t plus half a t2 power 2. t2 the time in the second case. S2 equal 0 plus half times root 2 over 2 g2 power 2. S2 equals root 2 over 4 gt2 power 2. The body slides in the second case the same distance in the first case. Then S1 equals S2. Since S1 equals S2, then root 2 over 16 g t1 power 2 equals root 2 over 4 g t2 power 2. Then 4 t1 power 2 equals 16 t2 power 2, and t1 power 2 equals 4 t2 power 2. Square root of t1 power 2 equals t1, and square root of 4 t2 power 2 equals 2 t2. Then the time taken in the first case equals twice the time taken in the second case. This example contains two cases, rough plane and inclined smooth plane. The first case the plane is rough and inclined. The second case the plane is smooth and inclined. Now the time t1 equals t2 double or twice the second time t2. That's meaning that the body take a time bigger than in case of the plane is a rough plane. Now we move to the next example. A body of mass 12 kg is placed on a rough horizontal plane. If the coefficient of statics friction between the body and the plane is equal to √3/3, whereas the coefficient of the kinetic friction is equal to √3/4. Then calculate the magnitude of the force which make the body about to move, then find the magnitude of the force which make with an acceleration of magnitude 49√3/20 meter per second square if the force inclines at 30 degrees to the horizontal. Now we have a rough horizontal plane and a body of mass 12 kg placed on the plane. The coefficient of static friction equal √3/3, but the coefficient of the kinetic friction equals √3/4. And a force of magnitude F acts on the body in the direction inclines to the horizontal with an angle of measure 30 degrees upward. Then the force F can be resolved into perpendicular components. The first component, F cosine 30 in the direction of the plane or parallel to the plane. And the second component, F sine 30 in the direction perpendicular to the plane, as shown in the opposite figure. Now, the force, in the first case, the force makes the body about to move. About to move, then the body is in equilibrium state. And N plus F sine 30 degrees equals mg, the first equation of equilibrium. Then N plus half F equals 12 times 9.8, and the normal reaction N equals 12 times 9.8 minus half F. Now, if the body move with a force of magnitude F cosine 30, then F cosine 30 degrees equals mu k n. Then √3/2F equals √3/3 multiply 12 times 9.8 minus half F. We can cancel √3 from both sides, and cross multiplication 3F equals 2 multiply between two brackets 12 times 9.8 minus half F. Now we can expand the brackets to simplify the equation. Then 3F equals 24 times 9.8 minus F. 3F plus F equals 24 times 9.8, and 4F equals 24 times 9.8. Then divide by 4. The force F equals 6 times 9.8 Newton. Divided by 9.8, the force acting on the body equals 6 kg weight. Now the second case, the force moves the body with an acceleration of magnitude 49√3/20 meter per second square. What is the equation of motion in this case? Yes, N plus F sine 30 equals mg. That means that N plus half F equals 12 times 9.8. Then N equals 12 times 9.8 minus half F. The second equation, MA equals F cosine 30 minus mu kn. Now, because the body moves with an acceleration, then we use the equation of Newton's second law. MA equal the resultant of the forces act in the body. MA equal F cosine 30 minus mu Kn. The mass of the body equals 12 kilogram, multiply the acceleration 49 root 3 over 20 equals root 3 over 2F minus mu K, which equals root 3 over 4 times 12 times 9.8 minus half F. The left hand side, after we divided both term divided by root 3, then 12 multiply 49 over 20 equals half F minus quarter multiply between two brackets 12 times 9.8 minus half F. Now we can expand the brackets to simplify the equation. The left hand side 12 times 49 over 20 equals the right hand side half F minus 3 times 9.8 minus 1 over 8F. And 12 times 49 over 20 equal 3 over 8F minus 3 multiply 9.8. We have half F and 1 over 8F, negative 1 over 8F, like terms. Then 12 times 49 over 20 equal 3 over 8F minus 3 times 9.8. Now 3 over 8F equals 12 times 49 over 20 plus 3 times 9.8. The magnitude of the force equals 94.08 Newton, and we can divide the magnitude of the force by 9.8 to get the force in kilogram weight. Then the force equals 94.08 divided 9.8 equals 9.6 kilogram weight. Another example. At a factory, the boxes are transferred by sliding them on an inclined plane, ends in a horizontal plane. If the length of the inclined plane is 40 meters, inclined at 30 degrees to the horizontal, and the resistance for each of the two planes is equivalent to 1 over 5 of the weight of the body. Find the velocity of the box at the end of the pathway, supposing that its velocity doesn't change by transferring on horizontal plane if the length of the horizontal part is 10 meters. Now the motion on two planes. The first plane inclined to the horizontal with an angle of measure 30 degrees, and the second plane is a horizontal plane. The box starts motion from the top of the inclined plane and contains the motion on the horizontal plane. The two planes, the inclined plane and the horizontal plane, had the same resistance, with their resistance equals or equivalent to 1 over 5 of the weight of the body. Now we start with the motion on the inclined plane. N equals mg cosine 30. N equals cosine 30 root 3 over 2. Then the normal reaction N equals root 3 over 2 mg. What is the equation of motion of the body on the inclined plane? MA equals mg sine 30 minus r. R is the resistance of the inclined plane. MA equals sine 30, which equals half mg, minus r, which equals 1 over 5 of the weight of the body. The weight of the body, mg, then the resistance equals 1 over 5 mg. We can divide it both sides by m then the acceleration A equals half g minus 1 over 5 g. Then the acceleration equals 3 over 10 g. Or 3 over 10 times 9.8, then the acceleration equals 2.94 meter per second square. What is the velocity of the body or the box at the end of the inclined plane, at the bottom of the inclined plane? The velocity v squared equals v naught squared plus 2as. S is the distance or the length of the inclined plane, which equals 40 meter. Then v power 2 equals 0. 0 is the initial velocity of the box at the top of the plane, inclined plane, plus 2 multiply the acceleration 2.94 meter per second squared times 40 meter, which is the length of the inclined plane. Then v power 2 equals 235.2, and now the motion on the horizontal plane. Now the motion on the horizontal plane. The equation of motion on the plane, ma dash equals negative r. Then ma dash equals negative 1 over 5 mg. Then ma dash equals negative 1 over 5 times g. The acceleration a dash equals negative 1.96 meter per second square, and we can calculate the velocity by using the relation v power 2 equals v naught power 2 plus 2as. Then v squared equals 235.2 plus 2 multiply negative 1.96 times 10. Then v squared equals 196, and the velocity equals 14 meter per second. بكده أعزائي نكون استعرضنا مع بعض موضوع motion of a body on a rough plane. rough plane قد يكون horizontal plane or inclined plane. عرفنا في التو كيسز بنعمل ايه، عارفين الايكويشن اوف موشن بنشتغلها ازاي، عرفنا ان في حاجه عندنا اسمها ميو اس وميو كي. ميو اس كانت بنشتغل فيها لو البادي at rest or in equilibrium state، لكن لو كان البادي moving under the action of sum of forces, then we can use the coefficient of kinetic friction, which is denoted by mu k. Dear students of grade 3 secondary, by this example we come to the end of our program today. Till we meet again, it's goodbye.